Okay, so here's an example of where they want us to find a model. It says, does a linear, exponential, logarithmic, or logistic model best fit the values listed in the table? Find the model, use a graph to check your choice. Okay, so they give us these data points here. So the first thing to do is to graph those data points. So it looks like all the x values are positive, going from 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Graph paper will help on these. And then it's going for our outputs from 0 to 4.39. Okay, so let's count up to 5. 1, 2, 3, 4, 5. Okay. So that gives us a scale of our x and y. So we're graphing this first point 1, 0. So 1, 0 right there. 2, 1.4 about, so it's going to be 2 and a little less than a half, something like that. 3, and then it's going to be above the 2, just barely. Let's see, that was 3, 4, and it's still going to be below the 3. 5, it's above the 3. 6 is about 3.5. I don't know if you can see it. Let's see where I'm at. 1, 2, 3, 4. This was 5. 6 we just did. 7 was almost to the 4. I think my scale's off. This is not looking right. I'm going to erase it. All right, I'm going to get better points here. I'll try a different color. This one's right, because that's 1, 0, right? Okay, then 2, and it was 1 and a little bit. I wish I wouldn't do that. All right, 3, and it's just over the 2. And it still won't let me graph these very nicely. 4, okay, so 1, 2, 3, 4, and it's going up to maybe there. I did this earlier and it looked much better. 5, and then it's over the 3. Well, maybe it's not graphing the way I think it's going to. All right, 6. So I'm at 6, 3.5. There we go. 7, it's still below the 4. 8 is just above the 4. And then 9 is a little more over. All right. It's not really linear. It looks like it's kind of going like this. Now, if you had graph paper, it'd be a lot easier to see that, but something like that. So what are we thinking? Linear, exponential, logarithmic? Looks like it's a logarithmic function. Now, when you go to write your function, then your model, you're looking at this, y equals a, because there could be some constant, could have a stretch to it. And we're going to use a natural log for the logarithm ones. It doesn't matter what the base is so much, and so it's easier to just go with natural log or common log. And usually in science, they'll use the natural log of some bx. Okay? All right, now that's kind of the basics. Now we have to kind of figure out what A and B are. But we know some information. We know that there's an output of 0. So let me switch colors here. 0 when x is 1. Right? Okay, so that tells me that if I'm going to get it 0, A can't be 0, right? Because then the whole thing would be 0. So then I'd have to say, when does the natural log of B equal 0? B has to be 1. So you're going back to your logarithm properties. Okay, so now I know B is 1. So now I have this model, y equals A, natural log of x. Okay, and how would I figure out what A is? Well, they tell you to use the points that are far away. So we're going to look at this end point here. When we plug in 9, we're getting an output of 4.394, a natural log 9. So we're going to divide that out. Divide by the natural log of 9. And we're going to get a is approximately equal to, we'll put this in our calculator, 4.394 divided by natural log of 9. And it looks like it's about 1.999795, so about 2. A is about 2. Okay, that's going to give us our model then. Our model is going to come from here with, we know now an approximation for A and we know B. So my model is going to say y equals 2 natural log of x. And then you could make a table of values by plugging in 1, 9, in those points. 1, we kind of don't have to do that one. We know where 1's going to be. It's going to be 1, 0. But now let's plug in 2. And we'll see if we get, close to what our data told us. Okay, so go 2, you're finding y equals 2 natural log of 2. So 2 natural log of 2. And it's about 1.3863. Okay? Which is pretty close to what we have right here. And then you could say y equals 2 natural log 3. So let's try that. Clear this out. 2 natural log 3. And I'm getting, so when I plug in 3, I'm getting 2.1972. Is that close to what I had? Yeah, it's close to what I had. And you could do that for all the points. It's not going to line up exactly, but it fits close. We're going to say that's a pretty good model.